In 1969, Ken Thompson and Dennis Ritchie create Unix, which is a small portable operating system which became the basis of everything else. Mid-1970s, Richard Stallman began his crusade for software freedom. He, in 1983, launched the GNU project with the goal of making a free Unix-like system. And the critical piece was the GCC, the GNU compiler collection, which was first released in 1987, the GNU C compiler. GCC made it easy to build and share software on many platforms, and it spread through universities and hacker communities. And the ethos of sharing software and working together collaboratively over the internet had begun. That compiler was crucial when in 1991, Linus Torvalds, a computing student in Finland, released the first version of the Linux kernel. He used GCC to build it, and the wider free software ecosystem meant others could join in. That same year, across the Atlantic, Guido van Rossum published the first release of Python to make programming friendlier and more productive. In the mid-1990s, James Gosling and his team at Sun created Java. The big innovation was the just-in-time compiler. Java programs could be portable yet fast because bytecode was compiled to machine code on the fly. That JIT idea fed back into Python. In the 2000s, Armand Rigo developed the PyPy project with its origins around 2003, and major JIT work landed in 2007. PyPy applied JIT compilation to Python, proving that a dynamic high-level language could run with speed closer to C. Okay, so I've written a simple Python program that will just look busy and take some time. So it's going to go around in circles, summing up these squares to 100 million. And there, it's done it. So it's worked out the sum of squares, which is this huge number, and then it took 8 seconds to do it. Great, that's quick. So I'm going to do pyenv local PyPy. So we use some version of CPython. And it took 9 seconds. And now we see that this version is PyPy. So it took 3.7 seconds instead of 9 seconds. It's over twice as fast, almost 3 times as fast. So we have this stream of improvements to programming languages. We start with C, then we get Python, then we get Java, then we get PyPy, which is, as we've seen, significantly faster than CPython. So why didn't PyPy take off? I think there are 3 reasons we can talk about. The first reason, the one they always give, is that, oh well, the ecosystem wasn't ready, that Python relies on C extensions and they needed to be recompiled and changed a bit to work in PyPy, and there was just too much inertia. And I don't think that's really the reason. I mean, people could have got over those things. I think the more important 2 reasons are, number 1, PyPy is extremely complicated. It uses, if you look at the difference between Guido van Rossum working on Python, largely doing the first version on his own, and then Sun and a huge team making the just-in-time compiler, that shows just like the level of work and difference. The C Python is extremely beautiful, simple abstraction. I think I'll explain this in a different video, but it's a very simple switch statement that goes through bytecode statements and evaluates them. It's extremely simple. I'll explain it in another video. It's extremely simple. Anyone can understand how CPython works. Whereas PyPy requires real knowledge of programming language design. You know, it's PhDs, it's PhD level stuff. And I think that's possibly the biggest reason why PyPy didn't take off as much as we expected it to in the mid-2000s. In the mid-2000s, everyone was like, this is amazing. This is going to completely replace CPython. It's just a matter of time. And it didn't. And I think one of the reasons is just because CPython is so simple and so beautifully designed that anybody can pick it up and work on it. Whereas PyPy requires real brains, I don't think, you don't have to be a PhD in computer science, but learning the PyPy code base will basically make you at that level. It's extremely sophisticated. I think it's just much harder to maintain. So because the innovations are happening in C Python and PyPy is not the default version, it always has to catch up with C Python, and all its engineering effort is in catching up, and it's very difficult. Also, I haven't got to the third reason yet, but I think reason 2.5 is that PyPy came out of Europe, kind of European universities, and the people aren't quite as plugged in as the C Python developers, who these days are mostly the west coast of America, and they're kind of like, they're much more in with the IT scene. So the C Python developers, several of them are professional developers. It's their job. They're being funded by big IT companies via the Python Software Foundation and stuff like that to actually work, or just being given time at their jobs to work on C Python. And they're not just going to give up their jobs and say, well, PyPy's here, I'll just become a farmer. They carry on with developing C Python. So there's obviously an economic incentive to keep C Python going, and it's just much easier. The tech industry can easily fund it. It's it can be done open source, it can be done volunteers as well. It's very simple interpreter, whereas PyPy is really sophisticated and it needs a lot of research money, and the Python Software Foundation has given it lots of money and really tried giving it a fair wind, and it just hasn't taken off. And I think the biggest reason of all, my third reason why it hasn't taken off, the biggest reason it hasn't taken off is just because of the timing. As we talked about in the C versus Python video, when C Python came out, it was a huge improvement for working engineers just to get something done. It was hugely productive, and it was, you had all these automatic memory management, interpreter, Python standard library, lots of high level things which immediately gave it an immediate use. PyPy was faster, but it's the same feature set, so it didn't have that same kind of exponential reason to adopt it. But I think that the biggest reason was that the vibe, kind of 2005, 2008, the conferences, everyone was obsessed with web frameworks. 10 of the 2000s, everybody wanted a website, and we were all getting jobs making websites. By 2005, everyone wanted a database-backed web app. That was the big change. The Web 2.0, the database, JavaScript, just the database-backed app, web app, gave so much more power than a flat web page. And all these frameworks were around at the time, these ones that were competing. At the early days of Python web apps, you just used FastCGI and ModPython directly, and then these high-level web frameworks came out. Zope was the big one, and Zope had the innovation of the object database way before MongoDB made it really popular, and DynamoDB and all that. ZopeDB was amazing, but you had the Zope framework, which then the high-level version of that was Plone for making CMSs, and then you had TurboGears, you had Pylons, you had CherryPy, and you had WebPy. And all these frameworks were competing with each other, and they were taking up all the conference interest. I know, because I was running the UK conference, the Python conference at the time, and we did our very best to push PyPy to the front and center. But everyone was interested in web frameworks. That was the huge thing that everyone was interested in. The focus was just much higher level on how can we make web apps. These web frameworks, not only they weren't very Python intensive, since you're pushing all the work down to the database, it also, this was before the cloud. You didn't have really sometimes a lot of choice over the environment, so you were happy if the server you were running the site on had any version of Python, let alone PyPy. Often you either had shared hosting where it was all controlled by the company, or you would have like an image, the stock image they put on your dedicated server, and it would be some kind of stock Debian or something, and or some Red Hat, probably more like Red Hat. It'd be like a Red Hat server, something like that, and it would have a version of Python in, and to get a different version of Python you'd have to call somebody, or you'd have to write a ticket, and it wasn't really that different between having PyPy and CPython, because most of the work is being done by the web browser and the database. So Python is just by passing things back and forth through APIs. So it wasn't so important to have massive performance at that point. So the interest was all around these frameworks. The way I kind of look at it, you had these monolithic frameworks like Zope, which Plane was part of Zope. Then you had Pylons, and Zope and Pylons, the best ideas became Pyramid. Then you had the WebWare, you had Skunk Web, you had Web2Py, you had TurboGears, and then Django came out and kind of took all their lunch. These all kind of died off because Django was kind of the best implementation of a monolithic Python web framework. And once you had that, you didn't need any others. And it became, it soon became a rolling stone and kind of knocked out all the monolithic frameworks. And today, Django is the main monolithic Python framework. Still going strong. It's extremely solid. I went to the Euro DjangoCon in Dublin this year, and in the sprint days, I tried to work. There's 2 sprint days at the end, and I tried to work on Django bugs in the bug tracker, and they were all kind of closable as not fixed because the framework is so solid and it's been going for 20 years or 19 years or whatever it is. It's so solid that every part of the stack is kind of either perfectly written code, or it's something where you've painted yourself in a corner and you can't really change it without changing too much. So it's really secure. It's really solid. It's really great. And then on the other side, you have the minimalist web frameworks like CherryPy, WebPy, Quixote, Twisted Web. They were trying to be much more less of a massive framework and more kind of pure Python. Django is its own. It's kind of its own environment. And if you're people who are hardcore Django developers call themselves Django developers rather than Python developers. I've always kind of called myself a Python developer because I'm just interested in everything, or just a general software developer because I'm interested in everything. But you can literally just learn Django, do your whole career making Django websites, and get rich. It'll work. Yeah, these minimalist ones are more, instead of having like everything decided for you, you choose your own adventure, and it does tend to work into patterns and frameworks, and they all tend to use SQ Alchemy, and if you use a particular framework, you're going to use the bits that everyone else is using, just because how do I do this? You get an answer, and then everybody converges on certain tools. So these all converged onto Flask, and Flask was the kind of best implementation of a minimalist Python web framework. It's really good as well. But then Fast API came and took its lunch. In Fast API, because it's asynchronous, it's really fast. And I mean, the use cases for Flask and Fast API are often using them, for example, in an Amazon AWS Lambda. Within Lambda, when you want to pop something up, or oftentimes it's just use the Boto 3 Amazon library, the framework that Amazon provides out of the box. That's always, often it's nice if you can just do a minimalist, just using the Boto 3 and just open Lambda, get your stuff done, close Lambda. But you definitely don't want to open a whole Django website and take 10 seconds for Django to boot up. So Flask was really good to niche in there. And then Fast API is kind of taken over from Flask. I don't know. I think it's probably a controversial point whether Flask could be on this line or it should be in the past. It's definitely massively used. There are not quite as many as Django developers, but there are a lot of people who I write Flask websites. Not as many as Django, but a lot of the people who I know who did Flask have now migrated to Fast API. And again, I like all these frameworks. I think they're all fantastic, and I try to keep up with both of these, and to a lesser extent Flask. It's I've written some great sites in Flask. It's really good. I've written some great Flask and sites in Django. It's really good. Fast API does have all the coolness at the moment. It has all the coolness to it. But if your website is the kind of thing that you have an admin, then and it's a little more CMS-y, Django is definitely still the one you want to use. And if it's like a light thing that you want to stick into AWS Lambdas, then Fast API is the one you want to use. So there's definitely a need for both. Perhaps over time, I don't know, Django might become more modular. There might be shared code between them, but they're both fantastic frameworks and they'll both make a really good web app. I think these frameworks are what killed PyPy, because the timing, everyone was interested in web frameworks. Everyone's interested in these battling it out, which, you could say these are the winners, and I don't know, it's a bit mean. I think Flask is still a goer. Nobody really paid any attention to PyPy because everyone was obsessed with like, oh, are you using TurboGears, or are you using WebPy, or are you using Twisted Web? You know, that's what all the conference discussions were about, not about PyPy, sadly. The focus was on the high level, not on the low level at that point, and that kind of killed the kind of breakthrough publicity it would have. But I still think PyPy is really good, and it's a great project, and we were trying to push it really hard at the time, and everyone thought it would take over, but it just didn't. I mean, it's still going, it's still faster than Python. CPython is still being developed. I'm not sure it will ever, you know, now there's the focus on the no-GIL Python. At best, CPython will get its own just-in-time compiler. That's how it'll come out in the wash. I could be wrong. PyPy could have a killer use and come back. It's really difficult because there are things that could be better in PyPy, but because it's not the leading focus of development, they can't just change anything. They have to like keep it compatible with CPython. It's very difficult for them to have a killer unique selling point because compatibility with CPython. If in say 2007 or something, everyone had just said, oh, PyPy is much faster, PyPy is our recommended runtime, and we're going to deprecate CPython, then PyPy would have taken off and it would have gone in a different direction, but it didn't. PyPy also got lost in the Python 2 to 3 transition. They made a huge thing out of the Python 2 to 3 transition, which in my personal opinion they didn't need to, because it's a high level interpreted language, so you could have had a version which ran both, and we did have those in the end. But because they made such a big deal of the Python 3 transition, PyPy kind of got forgotten in that as well. So that's what I think. Let me know what you think, and come back for the next video. Thank you for watching. Bye bye.